The battle for semiconductor supremacy is heating up. Intel and TSMC are pushing the limits of chip manufacturing with their latest process nodes, Intel's 18A and TSMC's N2. But who has the edge? Which one will power the next generation of AI, gaming, and mobile devices? Let's break it down. Both Intel 18A and TSMC N2 represent the cutting edge of semiconductor manufacturing. Intel's 18A is a 1.8 nanometer class process, while TSMC's N2 is 2 nanometer class. But don't let the numbers fool you. There's more to these nodes than just size. Both Intel 18A and TSMC N2 use gate-all-around GAA transistors, a major upgrade from FinFET technology. GAA transistors allow for better electrical control, reducing power leakage and boosting performance. But Intel takes things one step further with Backside Power Delivery Network, BSPDN, a groundbreaking design that routes power through the back of the wafer instead of the front. This reduces resistance, improves efficiency, and allows for denser logic circuits. One of the hardest things to scale in chip manufacturing is SRAM, the ultra-fast memory used for cache inside processors. Smaller SRAM cells mean higher memory density, which can lead to faster and more efficient chips. And this is where TSMC pulls ahead. While Intel's 18A makes big improvements over Intel 4, its SRAM density is closer to TSMC's older N3 node rather than the cutting-edge N2. Meanwhile, TSMC's N2 takes the lead with 38 megabits per square millimeter, meaning it can fit more memory per square millimeter, huge for AI, mobile chips, and high-performance computing. While SRAM density is important, logic density is even more critical. Unfortunately, neither Intel nor TSMC has disclosed exact numbers for logic density in 18A versus N2. However, Intel's BSPDN could give it an advantage in power efficiency and transistor density, making it a strong competitor despite having a lower SRAM density. Intel's aggressive power delivery strategy could give it an edge in efficiency and scaling. But until we get real-world benchmarks, it's too early to declare a winner. Where will we see these advanced chips in action? TSMC's N2 is expected to power future Apple, Nvidia, and AMD processors, meaning your next iPhone, gaming GPU, or Ryzen CPU could be built on this technology. Intel's 18A will likely be used in its own processors, but Intel is also opening up its foundry services, meaning companies like Qualcomm or even Google could become customers. With both Apple and Nvidia sticking with TSMC, it looks like N2 will dominate the mobile and GPU markets. However, Intel's push to regain leadership could shake things up in desktop and AI chips. Let's recap. TSMC's N2 has higher SRAM density, making it the best choice for cache-heavy applications like AI and mobile processors. Intel's 18A has BSPDN and potential logic density advantages, which could make it more efficient for high-performance computing. TSMC has a strong track record of execution, while Intel is still proving itself after years of delays. So, who's winning? Right now, TSMC seems to have the edge, especially for memory density. But Intel's innovations could help it compete strongly in the next generation of processors. The real battle starts when these chips hit the market in 2025. Will Intel's BSPDN and GAA transistors be enough to close the gap? Or will TSMC's N2 remain king? What do you think? Will Intel finally reclaim process leadership? Or will TSMC continue to dominate? Let's discuss in the comments, and don't forget to like, subscribe, and hit the notification bell for more deep dives into the latest tech wars.